Railway Conversations with Doc Frank.
Hello and welcome back to the show. This is the very first special episode that we have on this podcast. The reason for this being special, or you may ask what makes it special, it's shorter than a normal episode and it was a bit off topic from the main conversation that I had with my guest, Andy Petrie from Sydney in Australia. Interoperability is a huge topic here in Australia. Several states are introducing ETCS, the European Train Control System, or plan to do so. And getting this interoperable is a challenge which is probably just as big as the one in Europe, where there's a lot of struggle to make ETCS really interoperable in practice. So I have an idea from my own experience what can be done here in Australia to make it work. And I'm using this opportunity to talk to Andy to basically bounce off my ideas from him and also get his views in the process. So I hope that will be informative if you are in any shape or form involved in that interoperability discussion here in Australia, but also if you are involved in interoperability considerations in other countries. So please enjoy this episode. Hi, this is Doc Frank. I need to tell you about my brand new cutting edge 2024 training, Digital Signaling Interoperability. Interoperability is such a huge issue, not just here in Australia, but in other countries as well. Everywhere where you've got different railway authorities with cross traffics between each other. This course has the latest insights, the latest research. This training includes the SPA framework, Systems, Products and Applications, which creates a lot of clarity and avoids confusion in that area. We then look at the different technologies for digital signaling in Australia. And this is just an example that is transferable to many other countries in the world. We then give detailed introductions to the main technologies used in Australia, which are CBTC, ETCS and ATMS. Then we discuss the hierarchy of interoperability controls, the different ways how interoperability can be handled and addressed. A special session on CBTC interoperability between CBTC products from different suppliers. Then we look at ETCS interoperability, and if you think that comes automatic just by using ETCS, you need to think again. This lesson will address how interoperability in practice can be achieved with ETCS, and it does require some work. And then lastly, interoperability between different technologies. What is required to do that, to achieve that? Which options are available and what is arguably the best? You can get access to this fantastic brand new training under docfranktraining.podia.com/interoperability. I repeat that again, docfranktraining.podia.com/interoperability. If this is a topic of concern for you and your railway organization, then don't miss this training. We have this big initiative in Australia at the moment regarding interoperability between railway systems across the entire nation. And signaling interoperability is certainly a very important aspect, because people now notice that by introducing digital signaling technologies in differing ways, you may create something that's called a digital gap, or incompatibilities between the different railway systems that may be more severe than what you had before. Now, there's a lot of talk, we just need a national standard for everything. So all the signaling will be the same, and then that will be applied in the same way everywhere, and then the problem will go away. From your perspective and your experience as a system safety assurance person, what potential problems could you see coming from that interoperability? I'm not saying these are the problems, but what could go wrong, or how should that be framed in order to avoid any major risks?
Um, the digital break of gauge, I think, is what they talk about they've got one with the radios right now, haven't they? Where someone going from Brisbane to Melbourne has to stop,
Gauge
has to like
break, yeah,
change the
digital gauge
radio
break,
over. It's
that
like
was the term. Yeah.
3 or 4 different times. I think the signalling is interesting because obviously ETCS level 2 is based on the principles of interoperability. So Brisbane and Sydney are putting that in place. It'll be 5-10 years before it's really rolled out. So you have in theory a mix of ETCS standard. Then you get down to Melbourne, and we know that they're doing CBTC down there, only on a small line, and obviously Perth as well are doing CBTC. So we've got the problem where it's already too late. We've started to do 2 different systems, and obviously the one that's ARTC are doing as well is different again. We'll get to a point where, if we're not careful, we'll again have a cab full of digital signaling systems and different ways of working. And the human factor takes over at this point, because you'll get there, which one am I following? So then the system safety requires the train to know exactly where it is and which one to use, and to use an engineering control to switch it over. And this goes, if you look at Crossrail in the UK, they knew in 2011 that they were going to have problems getting their CBTC and ETCS level systems to work. And 9-10 years later, they still hadn't got it to work. And it's only now, and again, through lots of delays and possibly COVID help, that they got that technology to work. And that was with a concerted focus, one project working on it for over 10 years, to have disparate states doing the Australian approach of interoperability. Of course, we'll have a common process, just do what I do. Kind of approach. So if everyone says yes, we're going to have a common interoperable process so we can agree on the technology, and ETCS sounds obvious because it's already designed to be interoperable. But if people don't agree with it, then it's going to be a missed opportunity. There's other things associated with that, like the national skills training, and again having conversations about training a signal engineer in Melbourne to be able to work in Brisbane or Sydney. That's great when you have the traditional signaling systems that you can cross skill without having to retrain and get another license in another state and pay more money. But again, if you've got, we talked earlier about the complexity of modern signaling systems, that actually you're specifying things from a supplier. You can't really train someone to work on CBTC in any way without actually working for one of those suppliers. So it's understanding where the wins are in that and trying not to overcomplicate the process, I think. It's a big opportunity, but I really hope that all the states work together to take it.
Yeah, and I see a risk that a national standard, which is kind of new and which is very likely to differ and go away from the existing solutions, will require changes, like amendments of systems that have already been designed, that may already be in service at that time. And to me, it also bears the risk that what you call crossing the line, that basically you try to force a new solution, a new national standard on those local existing solutions, and by doing so, forcing design changes that may compromise the integrity of the existing system. And that's not to say there is no solution to that. I'm just not sure whether the enforcement of a unified national standard will be that solution. Yeah, it's certainly not the solution that you would have elsewhere with similar problems. So if you look at ETCS interoperability, obviously Europe comes to mind. And in Europe, you also have different implementations of ETCS in different countries that you find have some differences in there. You even have different implementations within the same country with differences, because projects were done at different points in time according to different versions of the ETCS standards and what have you. And the trick really is there to achieve interoperability between the different applications of ETCS without having to throw them all away and replacing them with the one European application of ETCS, which I don't think will exist. And in Australia, I have the same doubts. It would basically mean that you have to define common signaling principles that are acceptable in Sydney, in Melbourne, and Brisbane. I just leave it with those three cities. That has never worked in the past. Never. You speak to somebody in Brisbane and they will fight teeth and claw that their signaling principles have their justification, and the differences to what they do in Sydney and in Melbourne also have their justification. And it's not that the people in Brisbane are particularly stubborn. You go over to Sydney and they will tell you the same thing about their signaling principles being better than everything else. So trying to squeeze them all into the same format and then basically inform that one centralized solution on everybody else, I don't know. Firstly, I don't know whether they really get to a common standard like this, which is really agreed by all the parties. And then secondly, the implementation of that standardized approach to everything else, really not sure. Yeah.
I think obviously with interoperability, I've said this a lot, if Germany, Poland, France, Italy, and the UK can get together and agree with different languages and not the best history over the last 100 years, why can't these three states in the same country who speak the same language actually get together? It just puzzles me why we can't agree to that solution where Europe did.
Yep.
China adopting the European solution. The rest of the world are adopting that European solution, but these three states, for some reason, will argue.
But
gravity must be different in this state.
But that's exactly the thing. The solution in Europe is not that the Italians adopt the Polish signaling principles or vice versa. The Polish will have an ETCS implementation that reflects the Polish signaling principles, and the Italians will have something that reflects the Italian signaling principles. And that was the intent of ETCS in the first place. What I think where the solution is to focus on the theory of ETCS, which says the onboard system on the train should be able to work with all those different trackside implementations of ETCS. If that onboard system was really fully standard compliant, meaning in Europe, for example, that it has all the functionalities from Poland, from France, from Germany, from Switzerland, from Italy, and so on and so forth, which is not necessarily the case for practical reasons. So I think the approach for Australia, and it should be easier in Australia because we have fewer parties than Europe. So we have fewer states in Australia than member states in Europe by far, where here we are basically talking predominantly three states. If you can align Queensland, New South Wales, and Victoria, you're almost there. Maybe South Australia if you're generous, and what they do over there in Perth or over here in Perth, just keep 5 signals and you're fine for the Indian Pacific, right? But so you only have to align 3, maximum 4 states compared to 26 or so member states in Europe. So that should be possible. But I think the trick is not to enforce a harmonization of the trackside applications, which means trying to squeeze all the different signaling principles into one pot, but rather making sure that you've got an onboard equipment on every locomotive train traveling the country, which is smart enough and standard compliant enough that it actually complies with the stuff in Queensland and the stuff in New South Wales and the stuff in Victoria and everything in between. I mean, if you're talking of high-speed rail in Australia, it seems almost a no-brainer that this would be ETCS level 2 as well. Yeah, because you have it at the 2 endpoints anyway, or the 3 endpoints. And we will see what's happening with the freight network in the future. Yeah, whether they create an interoperability solution between ATMS and ETCS, or whether the solution will be different in the future. So we'll see. But I think the approach really should be the onboard approach. And I mean that's early days. They just start thinking about this in this national interoperability initiative, and I just want to use opportunities when I talk to knowledgeable people in the industry like yourself to basically just chew the fats or bouncing off opinions and say, well, what do you think? Could that work? Where do you think difficulties from your specific discipline and stuff like that?
From a system perspective, I think that the onboard solution is the only real pragmatic one that we can work with over here. The trainer's got to be able to move seamlessly between those three. And as you say, the signaling principles in Melbourne are very different from Brisbane. I know when I found out that drivers go past red lights in Victoria, I was like, what? I still can't understand that that's part of it, but that's not going to change because it's worked for 100 years and that's what they have to work with. So again, how can we make it simple on the train driver such that they've got one radio system, one signaling system for when they're in an interoperable area? Obviously, it won't be everywhere because there's just too vast distances between them that do all of those. And again, that's going to require at least two suppliers to work together to do that. And our Siemens also Hitachi are going to sit down and say, let's develop an onboard solution that works interoperably. They will if someone pays them. But yeah, that's the thing, is it's all down to cash at the end of the day, isn't it?
Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share. And until next time, keep it simple and bye for now. Thank you for listening.